And probably the most important thing that Loma Prieta did was it provided an example of a real earthquake and what it could do in an urban area, and it coincided with a probabilities report that we had released just a year before that actually included the part of the San Andreas that ruptured in the Loma Prieta earthquake. So we had these two things. One, the scientists were telling us there was a high probability of an earthquake somewhere on the San Andreas, and here was an actual earthquake and people could see what it was doing. So that was one thing. The other big contribution we got from Loma Prieta was the observation of the ground shaking. We had a lot of instruments that had been deployed in the interim since earlier earthquakes, and so we actually could see what the earthquake shaking looked like, particularly around the margins of the bay where we have a lot of soft soils. So we learned a lot about the influence of soft soils on ground shaking. And the shaking was even more complex because we had this unusual MOHO bounce where the seismic waves go down, there's a critical reflection, and they coincide coming back up. And so this contributed to the damage in San Francisco, for example. So you had damage at great distance from the earthquake. So it had a big impact on our scientific understanding of ground motion.
One of the main lessons that came out of the Loma Prieta earthquake was the sense that you could get pretty strong ground motion pretty far away. So you get these mantle bounces. And we hadn't really paid any attention. There were papers that talked about this, but we hadn't really paid any attention to it, in a real sense. It wasn't in front of our minds.
Well, professionally, I thought it was fascinating because much of the damage was in San Francisco and Oakland, in that area, but yet the earthquake was far to the south, southwest of San Jose. So that was a real baffling thing to me. Why isn't there kind of a continuum of damage? Why is it concentrated in a certain area and not in others? And we subsequently did some research to investigate that, but professionally, that was one of the first things that struck me.
Yeah, I don't remember the timing per se, but there was a lot of discussion about how do we move forward from this. And one of the most vivid discussions I remember was with colleagues from the engineering community. There was a really uncomfortable discussion between the engineers and the seismologists about the way forward. The earthquake program, up until that time, had fashioned itself as, I call it derisively, the University of Menlo Park. You got recognition for research. And during this discussion, the engineers were taking us to task. They said, you guys publish in JGR and BSSA all the time, and that there's just no information transfer. And so we don't know what you know. And in particular, they wanted to know how hard does the ground shake in a given magnitude at this location. Today, that's standard stuff for the program. But it was like a moment that everybody just sort of stopped and said, you want what? That's, we weren't thinking in those terms of actually trying to interface closely with the engineering community.
I would say the most important thing we learned is that the fault system in the Bay Area is really more complex than we were thinking. And that therefore, forecasting earthquakes was going to be more complex than what we were thinking at the time.
I think just about everything changed in Northern California as a result of Loma Prieta. I think that started the work that's put us where we are now in terms of our present understanding of the Bay Area faults. And between the mid-90s and the mid-2000s, that was sort of the golden time. And all of it occurred because Loma Prieta occurred and really changed the direction up here.